Welcome to tutorial 1 for fiber extraction and post-processing of a single image using ctFIRE. First we launch the application. Double click on the icon with the name ctFIRE version 1.3 beta. This opens up two windows. This process may take about 10 to 15 seconds depending upon the system. This tutorial deals with extraction of fibers from a single SHG image. Step 1 is to open an image. For this, leave the batch, the .mat and the out.adv checkboxes unchecked. Note that the status box present at the bottom of the ctFIRE window prompts the user for the next steps. Right now it shows import image or data. Click on import image or data button. This opens up a window which prompts the user to select one of the images. For this tutorial we'll be using testimage1.def for fiber extraction, so double click on the image to select it. After the file is selected, a new window pops up and the image is shown in it. Step 2 is to select the run mode and the output parameters. There are three run modes in ctFIRE version 1.3. One is ctFIRE, another is only the FIRE algorithm, and the third one is ctFIRE followed by the fiber algorithm. For this tutorial we'll be using the first option, that is ctFIRE. As for the output parameters, it refers to these 6 options. Option 1 of overlaid fibers produces an image with the fibers overlaid on the original image. The non-overlaid fibers shows only the extracted fibers and not the original image. The other 4 options of angle histogram and values, length histogram and values, straightness histogram and values, and similarly width histogram and values, these are selected if the user wants a histogram representation of the data of the selected fibers. For this tutorial we'll be using only overlaid fibers as the output parameter. Next step is setting the fiber extraction parameters. Some of the parameters are given in output figure control. The parameter of minimum fiber length, which has the default value of 30, is used to select only the fibers with width greater than 30 pixels or more. The second parameter of image resolution in the units DPI, currently having the default value 300, is used to plot the fibers with the given resolution on the original image. Next, maximum fiber width in units pixels. Only the fibers with width less than 15 pixels will be plotted. Histogram bin numbers, this is basically the number of bars which will be present in the histogram. That is, for a particular range, that range will be divided into 10 subsections and each subsection will be shown by a particular bar. The next step is to update the other parameters. Click on the update button and a new window pops up. There are some 8 parameters, for the details of which kindly refer to the manual provided. For this tutorial we'll be using the default values. After OK is pressed, another window pops up with 2 parameters for curvilinear transform being applied to the image. For this tutorial we'll be using the default values. Once OK is clicked, the run button gets enabled. Click the run button, which is the step 4. As you can see, the fiber extraction theorem is being run on the image. A new window pops up with the output of the curvilinear transform being applied to the original image, while the command window shows the progress of the ctFIRE algorithm. Also, the status present on the ctFIRE control window also shows that analysis is ongoing. This may take up to 2 to 3 minutes depending upon the size of each image. So I'll be pausing for this duration. Okay, so once the ctFIRE algorithm is run on the image, it shows the time it took for the ctFIRE algorithm to run on the image, and it also stores the output files, etc. The program also opens up a new window with the original image being overlaid by the fibers that are extracted from the ctFIRE algorithm, which is shown here in this window. The next step is checking the results. So we'll be opening the folder which contained our original images. In the directory containing the image, a new folder is created if it's not already present, called ctFIRE output. This folder contains all the output of the ctFIRE version 1.3 beta. As you can see that there are 4 files which have been created as a result of ctFIRE algorithm being run on the image. The first one is the ctFIRE out underscore the file name, which is test image 1 in this case. It contains all the data which is extracted by the ctFIRE algorithm. The next is the ctF parameter underscore file name. This contains all the default or the changed values that were used to produce or extract the fibers from the image. This Excel sheet can be used for processing separate images or the same image to replicate the results. The next, that is ctr img underscore the file name. This is the result of the curvilinear transform being applied on the original image. The next one is the ol underscore ctFIRE underscore file name. This is the overlaid image in which the original image is being overlaid by the fibers that are extracted from the ctFIRE algorithm. After this, the next step is post-processing. We'll close the windows. For post-processing, the outputs have to be selected. Since the overlaid fibers have already been stored as an image, we'll deselect this and select the other options: non-overlaid fibers, angle histogram and values, and so on for length, straightness and width. Then press the post-processing button. Five new windows open up. The window stating the extracted fibers contains only the fibers that were extracted from the ctFIRE. Notice that there is no original image present. The rest are the 4 histograms of the properties width, straightness, length and angle. Since we selected the histogram bin number to be 10, notice that the number of bars present for each property is 10. We can increase or decrease the number of bars according to the user's choice. This results in more output files being generated. Notice that this file nol_ctFIRE_file_name was not present before. Similarly, 4 more Excel files are created as a result of the post-processing being done. Note that this post-processing, in which the Excel files for angle, length, straightness and width are created, is necessary for using the post-processing graphical user interface, which will be covered in tutorials 5, 6 and 7. To open the advanced output, which is the step 7, click on out.adv and click post-processing. This opens up a new window called analysis module, the details of which will be covered in tutorials 5, 6 and 7. If the same or some different processing needs to be done on another image, just click the reset button and you are good to go again. Thank you for watching tutorial 1.